Welcome, my friends. Now I will talk about a small presentation on air quality assessment. And this lecture is followed by a detailed presentation, air quality how to lay down air quality monitoring network. Next, generally, you have to do the air quality in three sessions, three seasons: summer, post monsoon, pre monsoon, and winter. This is summer, post monsoon, or pre monsoon, and winter. These are four times, or because monsoon has an effect. Because in case of monsoon, the air pollution improves because there is a turbulence and there is a rainfall, so the dust is settling. And the summer is a critical time because dust is there. But one advantage is there in summer, that there is a good wind speed, and there is also a mixing height higher, so that in summer the dispersibility is good. In winter, it's a critical time. So all these seasons, if you give a, if you take this some samples, and each season 20 to 30 days, then you will get a representative samples. The frequency, daily frequency, that 8 to 24 hours, because averaging period covering weekdays and weekends. That means in the weekdays, you will expect some more pollutant because industry is operation, the vehicle movement is there. And weekend, the vehicle movement is low and the industrial operation and commercial operation is also low. The so varied activity is there in the weekend and the weekdays. So it is better to scatter the sampling in that weekdays and weekends, and 24 hours or 8 hours, whatever may be the convenience party. 7 to 10 monitoring station with one at background and two each at residential, traffic, industrial and commercial location to be selected around this place. If the place is in rural area, still there should be one background station, and keep few residential area. And there is a road traffic, if it's a highway is moving in traffic, there should be one station. And there is some commercial or industrial activities there around that place within 100 kilometers. You can keep a one station within 50 kilometers. You keep a one station there, so that you can understand that what kind of pollutants are coming to the project site. 3 to 5 meter should be kept the height monitoring installment of the monitoring equipments, 3 to 5 meter heights. This is the basic idea of giving according to the convenience. Keeping this guidelines in mind, it is a CPCB guidelines. Keeping this idea, this background in mind, and according to the convenience to the areas, you can select the stations. Next. Next. Generally, these are the parameters: SPM, PM10, PM10 sulfur dioxide, oxides of nitrogen, PM2.5 carbon monoxide, and VOC are giving actually. These are the parameters. Of course, SPM is not using nowadays, but one thing is there. You keep SPM when you are going a gross pollutant like thermal power stations or cement plant. You will keep some SPM because then it will give a idea, because particulate matters which are coming out from the emissions, which reflected SPM also, better ways. And equipment, high volume sampler for SPM, and then multi-speciation sampler or respirable dust sampler, which is for the PM10. Equipment impregnates attached to the RDS and HBS, and nitrogen dioxide also impregnated attached to HBS or RDS. PM2 2.5 FRM sampler. Carbon monoxide you have to go for a automatic analyzer, and VOC sampler in case of VOC. In case of the VOC, you will most of the time you go with the refineries, petrochemicals, where the maximum VOC is coming. But in case of bulk drug or pesticides, instead of VOC, you can go for a particular solvent what they are using, which is coming out. So you can go for a sampling or correct appropriate equipment for that solvent to test. Then sampling period, high volume sample 8 to 24 hours, PM10 8 to 24 hours, 8 to 24 hours for sulfur dioxide, nitrogen dioxide 8 to 24 hours, PM 2.5 8 to 24 hours, 4 to 24 hourly and continuous for the carbon monoxide. 4, 8 or 24 hours. In case of a VOC, if it is case of a refinery or petrochemical, you can go with the 4 hours because the variation is very high. And in case of the particular solvent, you can continue as 24 hours actually. Sampling frequency 20 to 30 days as most of the cases. In PM 2.5, 1 week continuous in each of the 3 seasons. 1 week you should go for a continuous monitoring of carbon monoxide, and once in each of the 3 seasons of the VOC. So this is the cases of the frequency. This is there. Next. Now, what are the things you will go? Thermal power plant, sulfur dioxide, NOx, PM10. You also keep PM 2.5 and SPM also. Refinery, sulfur dioxide, NOx, PM10, ozone and benzene and nickel. Steel plants, sulfur dioxide, NOx, PM10, benzopyrene. Pharmaceutical industry, SO2, PM10, NOx, and also kept benzene if benzene is used there. Or you can go for a particular solvent, you can use a solvent measurement. Pesticides, sulfur dioxide, NOx, PM10 and benzene. And cement plant, PM10, PM 2.5, SO2 is okay. If nickel is there, you can give it to. Distillery sugar industry, mostly boiler, PM10, SO2 and NOx is sufficient. So these are the pollutants to be monitored under EIA related monitoring. When you are giving the EIA related monitoring, you can use this kind of parameters. All the parameters should not be made. According to the industry, you made. Next. Next. Then meteorology is the biggest player in case of the air pollutants, because air pollutants carrying from one place, from source to the receptor by the wind, and also it is not only wind speed on horizontally but also mixing height. These data, if you are very close to a IMD station, you can obtain this data. This data, IMD is giving this data on cost basis also, but you will get a very good data. 100 years data you will get. Construct a Wheat-Rose diagram with the help of the data you are getting. One upwind and one downwind direction. You will get the, if you want to set, go for a meteorological stations, you should go one at least the upwind and one at least in downwind, maximum at downwind directions. Number of stations shall be dependent on population with multiple of 3. Station should be located next to habitation, and parameters shall be dependent on expected emissions and frequency as we have given as per the standard and which we have already. And this internal protocol, very special parameters, you can also add it. Next. Now, micrometeorological data generation, site specific. You have to data wind speed, wind direction, and mechanical automatic weather station. You can dry bulb temperature and wet bulb temperature. You can get from the good temperature things, relative humidity as a specific parameters are there. And in case of solar radiation, a cloud cover, environmental lapse rate, that is the things. Solar radiation cloud cover you can get from the data from the IMD nearby station of the IMD they are getting. And case of the rainfall, you can getting rain gauge. You can install rain gauge and see the data actually. I will go for the soda and the balloon for the adiabatic lapse rate calculation. That vertical profile, temperature profile, that I will show you in the forthcoming slides. Next. Next. Speed measurements by anemometers, that I will show you, and wind vanes, that is there, that all I will discuss to you. Measurement 10 meters above the spirit, open space, flat surface without any obstruction. That is the speed and direction of the wind. Next. See, this is the wind vane set. You know, at the upper there is a wind directions is given, in bracket fans are there. So if it is coming from the east to west, that is source, then the direction is giving like that, east to west. The fan will be in the back, will be in the east side, and the west side, the direction is been given. And below it, you will find there is a revolution. There is a revolution, and that will next. I am just giving next direction to next. So this is the anemometer. There are apart from the anemometer, they are also giving the wind shock. Wind shock you have seen in the airport mostly. There is a funnel of the made of the fabrics, and the fabrics is colored red, white, like this. And they are showing, the wind shocks is showing the direction very clearly. And the speed is calculated on the basis of number of rates in the direction, and then you will find the measurement on the basis of this shocks. This is a method visualize. You can visualize, and a very common man can also understand it. So air pilot, when he is coming to the airport, he can see the shocks, wind shocks, and see the direction. Accordingly, he get down or he take off. That was the idea of the wind shocks. It's a very visualized, it's a bigger one, visualized one. Whereas wind van has a pointer, as I have seen you. Pointer is looking in front, and the fins are in the back. When the wind is blowing, the wind value points to the end. Actually, this is a very interesting thing now. And anemometer, cup anemometer is there, which is moving. And in the cup anemometer, within the cup and outside the cup, there is a difference actually, pressure difference, and from there the velocity is calculated. Now it is the horizontal sides, wind speed and direction. Now, vertical temperature profile is done by the two techniques. One is the Soder techniques and one is the balloon techniques. Here, in the balloon, if balloon goes up, and you will feel, if you are in the balloon, you will feel the temperature is going down with the height. So the cool air, the hot air is moving to the cooler atmosphere and is moving up and up. So because the land surface is hot and so hot air is moving because it is coming out from the chimney and it is moving out. This is the environment. This is the things where the package of air is moving. So these, how much height? It is a really 1 meter, 10 meters. It is height is going. Temperature is 10 degree temperature is 1 meter height. It is moving out down. So another technique, which is a more sophisticated technique, this balloon techniques, how to do, has been produced by Central Pollution Control. There is a publication available on the website. You can see the publications and can do with the help of a IMD officials or any weatherman. He can help you out from these things. It is a simpler and you can do these things very easily. The second thing is a Soder technique. It is a full sonic detection and ranging. This is a Soder technique, sonic detection and ranging. These techniques are generally turbulence, atmospheric turbulence is measured by the sound waves. And where the turbulence is not there, then they found that this much is a vertical dispersion is taking place. The turbulence is going on. And this is a very accurate technique which has been installed in CPCB headquarters. IMD, most of the station which is in urban metropole, IMD has a station of Soder. From there, the vertical height is measurement. For your purposes, for the purposes of EIA, balloon technique is where you should do it. Everywhere you should not do the height. Mixing height calculation you will do where the gross pollution is very high. Say thermal power station, say refinery, say petrochemicals, say cement industry. These kind of industry where the maximum gross pollution is coming out, there you can do this kind of balloon technique, and you should do it actually. I prefer that you people should do it to get the vertical mixing. Next. Now, another thing is that you can get the data. What you will do with the data? There is a exceeding factor. It's a ratio of observed annual mean. That means your 30 measurements on each station. So 120 measurements is there. And say sulfur dioxide or say criteria for PM10. And what is the annual standard for the respective pollutants and area class? Area means it is a rural area or this area or sensitive area. Industrial area, rural area, the urban area, and sensitive area. So say I am giving some example. Say observed annual mean concentration of the criteria pollutant PM10 for 4 rural locations are 150, 80, 60 and 30 μg per meter cube. What are the EF values of the 4 areas? What decision the project proponent shall take with respect to EF values? This is the most important. You are measuring something and you have to take a decision. And the observation-based decision, or it is a science-based decision, is the correct decision. So how you will take these things? Next. So observed value is 150 in rural and standard is 60 μg per meter cube. So EF value is coming 2.5. If VF value is more than 1.5, then it is a critical situation. So project proponent shall avoid it, must be avoided of that place, because this place will create a problems in the critical time. Then the second case is if value is coming, 80 is the observed value and standard is 60. The value is less than 1.55 but greater than 1. It is a high pollution zone. You can go for a state-of-art facility. This state-of-art facility is coming, is written in the BAD document, European BAD, best available technology. It is there, European Union, that document is a very good document. And that document will say that what is the state-of-art facility with the air pollution with respect to air pollution control. So you go for a state-of-art. In the state-of-art, if you are failing, even if it is a little bit higher, that is, it is less than 1.5 or greater than 1, if it is a high pollution zone, still you are safe. Next. Better also, I advise that it is also to avoid this location. Next. Then it is 1, belong to moderate pollution. Go ahead with the BPT technology. BPT means best practicable technology, which is available in India and well documented. And CPCB's comprehensive industry document, this BPT has been discussed very clearly. Say thermal power station, the BPT is for the control of particulate emission is the ESP. And also desulfurization, you can go with this. This is your APC. And you can go. But if you want to go for a state-of-art APCD keeping in mind future expansion, you can go out of the ESP followed by a kind of a back filter or something, or doing something. And in case of the cement plants are doing good best available technology. Wherever required, they are doing the ESP. Wherever required, they are going for the back filter or back house. They are doing. And this is, if you want to, there in future, I have to go for a future expansion. So you can go with the state-of-art APCD. Now, fourth cases where 30 is the observed value and 60 is the standard, 0.5, low pollution area, it is, you can jolly well go with the BPT technology for APCD. So you have to go a very good measurement, because this measurement will give you the basic platforms, the database, and in detail, next lecture I have given in details. It is the instrumentation part I discussed, but details, location, how you will do, what are the station, whether grid monitoring station is required, or whether 3 monitoring station is sufficient. We're a very rural area, nothing, no industry, nothing is there. And where the commercial complex is there, the something is there, semi-urban areas is there. So, or industrial area you are going, then you can go for a grid. So this kind of thinking has been discussed in the consequent lecture. Thank you.